Newton's first law says that an object will maintain constant velocity unless there's an unbalanced force on that object. People get this wrong all the time. They think that to maintain constant velocity you need a force. It's the opposite. If a box of mass m is moving with constant velocity, it wants to keep that constant velocity, and the only reason that it would not keep that constant velocity is that there's an unbalanced force on that mass, like a frictional force causing the box to stop. This property of objects wanting to maintain constant velocity is called inertia. If there was no force on an object, what could we say about the velocity of that object? Could we say that the velocity is zero? No, we could not say the velocity is zero. Forces only tell us information about the acceleration of that object. Newton's second law is an equation relating the sum of the forces on an object and the acceleration of that object. The larger the mass an object has, the larger inertia it has, which means it wants to maintain its constant velocity more, so the acceleration is going to be less. Just like 2D kinematics, you have to treat the horizontal and vertical components of the forces separately. Plug only x-directed components into the x equation and only y-directed components into the y equation. If done properly, these equations will allow you to solve for the horizontal acceleration and the vertical acceleration. Just don't mix up x-directed forces with y-directed forces in a single equation. Newton's third law says that two objects will always exert an equal and opposite force on each other. Even if the mass of one is small and the mass of the other is great, the forces on each will be the same. Since the forces are the same, will the acceleration of these objects be the same? No, the acceleration will not be the same because the mass of these objects are different, which means the larger mass will experience less acceleration. Here are the most common forces you're going to deal with. The force of gravity is just mg, that's why everyone loves it, but that's only true near the surface of the Earth. If you're far from the surface of the Earth or if you're on another planet, you have to use the more general equation for the force of gravity. The normal force exerted by a surface is also usually just mg, but people don't love it so much because sometimes it's not mg. If you're on an incline, the normal force is going to be mg cosine theta. An object being pushed down on or pulled up on is also not going to have a normal force equal to mg. It'll be larger or smaller by the amount you push down or up on the object. In an elevator, the normal force is going to be mass times the gravity plus the acceleration or minus the acceleration of the elevator, depending on whether it's going up or down respectively. It's important to note that scales that you stand on measure the normal force, not your weight. The force of static friction is what causes objects to not slip on a surface. People often think that the static friction is equal to μs times the normal force, but it's not. That's the maximum value of the static frictional force. Static friction will only match the force trying to make the object move. If I push with 10 newtons, static friction will push back with 10 newtons. If I push with 20 newtons, it'll push back with 20 newtons. It'll continue doing this until I reach the maximum static frictional force, which is just μs times the normal force. Kinetic frictional forces don't care how you push on the object. If the object is slipping on the surface, then the value of the kinetic friction is always going to be μk times Fn. The spring will exert a force if you displace it from its equilibrium position. K is the spring constant. X is not the length of the spring. X is the amount you displace that spring from its natural equilibrium position. Objects placed in a fluid will experience an upwards buoyant force equal to the weight of the fluid they displace. That's called Archimedes Principle. V does not necessarily refer to the volume of the object. It refers to the volume of the object that's submerged in the fluid. Rho is also not the density of the object, it's the density of the fluid. Density of the fluid times the volume of the object submerged in the fluid gives you the mass of the fluid displaced, times g gives you the weight of the fluid displaced. That's why this equation is just another way to state Archimedes' principle. The formula for the electric force looks just like the formula for the gravitational force. Just replace the gravitational constant with the electric constant and replace the masses with charges. Even though mg is everyone's favorite force because it's so simple, people always forget to use QE to find the electric force. But just like you'd never use the big ugly equation to find the force of gravity, if you could just use mg, you should never try to use the big ugly equation for the electric force. If you already knew the electric field, you should just use QE. There's two formulas for the magnetic force because one's for the magnetic force on a charge and one's for the magnetic force on a wire. Notice that there is no formula for tension. The only way you can solve for tension is by plugging it into the left-hand side of the sum of the forces equals ma and then solving for t. Just make sure if the tension is directed at a weird angle, you only plug in the x components into the x equation, like t sine theta or cosine theta, and only plug in the y-directed components of tension into the y equation, like t cosine theta or t sine theta. All of these forces that we've talked about would go into the left-hand side of sum of the forces equals ma. Many people fool themselves into thinking that ma is a force and they try to plug ma into the left-hand side of sum of the forces equals ma. But ma is not a force, it's mass times acceleration, and it's required to be on the right-hand side and the only thing on the right-hand side of sum of the forces equals ma. Inclines are kind of weird. For one, the normal force is not equal to mg, it's equal to mg cosine theta. For two, you don't break up vectors into x and y components, you break them up into components directed parallel to the incline and perpendicular to the incline. The component of gravity parallel to the incline is mg sine theta. What do you do if you have two different masses required to move in the same way? Treat the two masses as one big system, then only look at external forces that try to make that system go and try to make that system stop. External forces that try to make it go will be positive, and external forces that try to make it stop will be negative. Those go on the left-hand side of sum of the forces equals ma. Just make sure that m and ma is the total mass. This will let you solve for the acceleration using only one equation.